Okay, in example 6, we're going to be writing an exponential function given its graph. So there's steps to how we have to go about doing this. So given the graph of an exponential function, we're going to write its equation. So for number 1, it says first we have to identify 2 points on the graph. We want to choose the y-intercept as one of the 2 points whenever possible. Try to choose points that are as far apart as possible to reduce round-off error. In step 2, if one of the data points is the y-intercept, 0a, then we automatically know that a is the initial value. Using a, you would then substitute the second point into the equation f of x equals ab to the x, and then solve for b. Now, if neither of the data points have the form 0a, then you're going to substitute both points into 2 equations like we did in example 5 with the form f of x equals ab to the x, and then solve the resulting system of 2 equations and 2 unknowns to find a and b. And then at the very end, we're going to write the exponential function f of x equals ab to the x. So in example number 6, we want to be able to find an equation for the exponential function that's graphed in this figure. So the first thing we need to do is, okay, we're looking at this graph. Okay, and what we want to do is find out, okay, is there a point on this graph where it crosses the y-axis? Well, there certainly is. And that point is the following. It is that point right there, which is 0, 3. So far we have an ordered pair that gives us 0, 3. Okay? And then what we want to do is we want to find another point that we can easily find on the graph that's a little further away than that point. So if we take a look at 0.5 at 1, 1.5, 2, well 2 has an output of 12. So that's a nice point that we can use as our other point. So therefore now we have 2 and then 12. Okay, so that's how we're determining first our ordered pair. So we need to pick that information from the graph. So now that we can choose the y-intercept on the graph to be 0, 3 as our first point, then that tells us that the initial value a is going to equal 3. Next, we choose a point on the curve some distance away from 0, 3, which is what we did, that has the integer coordinates. And one such point is 2, 12. So now we're going to write the general form of an exponential equation, which is y is equal to ab to the x power. Then what we're going to do is we're going to substitute the initial value, 3, in for a. So now we're going to replace a to be 3. Okay, and then what we still have left in this second part is we have an x and a y, and that's where we're going to have to use that second point, where the x is the value of 2 and y is the value of 12. So we're going to substitute in 12 for y and 2 for x. And now we're going to solve for b. So we divide both sides by 3 to get 4, and then we have to take the square root of both sides. So now b is going to equal plus or minus 2. Now recall that b represents the base, and the very first example that we had in this section says that our base can never be negative. So we cannot take the negative of one of these solutions. We have to take the positive. So because we restrict ourselves to positive values of b, then we have to use b is equal to 2. And then we're going to substitute a and b back into the standard form at the very beginning of the general form. And so we end up getting f of x, which is equal to the value of a, which is 3, the value of b that we found, which is 2, to the x power.